Okay. Hello, everybody. Welcome to this talk about containers and security. My name is Panos Georgiadis. I work for SUSE Linux as a QA engineer, testing basically containers in that case. And I'm here to save the day because the original author actually was sick. So about 1 hour ago, the guy said, if I can help with the talk. So this is going to be more like an open discussion also. If you have some questions or you have some experiences you can share with your colleagues. And I assume that the reason that people here that they wanted to have this talk is because containers are real, containers are happening today, people are using them heavily, but nobody cares about security. And that's where the biggest fuck-ups are happening. Like 1 month ago, I don't know if you know that, maybe we can talk about that later. So basically, how many of you know what a container is? Let's start with that. Half the room, kinda. So containers is not new in the Linux world. We had chroot, we had jails, we had the LXC. Then Docker came, and what they did, basically, they build the ecosystem, they build the commands, and they make it easy for the people to use it. So instead of reading a bunch of manual pages and staying up all night, drinking coffee and beer, now you can just run one command and make it work. And this is why everybody copy and paste stuff from the internet and they end up with their passwords in GitHub. Yeah, true story, I mean. And there was a time around 2012, 2013 that we had the so-called container wars. Also, we had the comeback from Star Wars, so they made it like container wars. We had Docker that say, okay, this is the way to go. And then we had Red Hat coming with AppC and Rocket and say, this is how we would like to have it. And then we have Canonical coming with LXD and say, that's what we would like to have. And then every company was choosing different frameworks to have their containers, and there was kind of a mess. People were replicating the same ideas, writing different codes, and then there are GitHub repositories, forks of the forks of forks. So if you ever go to a container conference and you try to keep up with what they were talking, it's a jungle. It's a complete mess of terms and projects used by the same projects, but not exactly. So it's really, really a mess there. And then this is where the CNCF jumped in and say, let's standardize things. Let's say how we will go forward from now on. So we have the OCI, Open Container Initiative. Is it still on? Okay. And what we're doing there is that we try to standardize the way what a container image means, a specification, and a container runtime is, how to run this image. So soon you will see that people will start using the open source way of containers in that case. What I can tell you is that in OpenSUSE, at least in a Cubic, since I'm the guy who wrote the test, I can guarantee to you that the open containers we're using runC instead of Docker. You can completely run containers without Docker using the open source way. It's working in Cubic. And let's now start a little bit about the security of the containers in that case. So what is happening, because everybody is jumping into containers, but not really interesting to see what works under the machine, they go to Docker Hub, which is the most famous Docker registry in that case, the most famous container registry. They see, oh, I need an image for Python, or I need an image for this or that. So they grab an image and they start building stuff on top of it. These images are basically file system of something, of a really crypt operating system in that case. So we have packages and versions there that might be vulnerable. Let's say that the SSH package is there, or the TLS, or something else, or even the kernel, not the kernel version, but the application that you're going to run is based on somebody else's image, and as a result, if his image is outdated, you are going to end up with vulnerabilities. So a container is using your host kernel. It doesn't come up with a kernel, it's going to use your kernel in that case. Also, it's going to use your host memory and CPU. It's not like a virtual machine. It's not that isolated. And this is the side effect of the container. It's smaller than a virtual machine, so we don't talk about gigabytes in terms of QCAP, we talk about in terms of megabytes, and you don't need to wait for a system to boot. You press start, 10 milliseconds is up. But yes, it shares your host OS, kernel, and memory and CPU. And what is the problem with that? The problem with that is that if the image that somebody else has the base image and you start building on top of it, you start using it, it has some vulnerabilities, then basically they can exploit the kernel of the host system, which is what you are running in that case, and then we have problems in that case. That's why in Docker Hub they have now a tab, security vulnerabilities. So you can see the security assessment, how secure or not is this image in case you would like to use it. And another thing with containers is that as soon as you open a bus cell in the container, you are root. So in case somebody manages to escalate the privileges, then it might be able to interfere with other containers on your system. Also, since the container can see your CPU and RAM, if somebody can run some application that is eating up your memory, it's going basically to kill the whole system. So these things are possible to happen, and they are indeed happening, especially in Docker Hub, that everybody can upload an image with no any control. In that case, there were many images that had Bitcoin miners inside. So indeed, you were running your Nginx web server, but there was a guy mining at the same time in your machine. Just give it a try. I have some notes here, and yes, today I was in another presentation about building containers in build service, and the guys there told us that they take security really up, so they don't allow you to use network at all when you're building your containers. Usually, I mean, since the typical pattern when you build your container, you have some commands that you install the package that you need, either using apt-get if it's a Debian, or Zypper if it's SUSE, or Yum it's Fedora. And they told us that they don't allow this. It's completely off the internet. They expect to have the package locally there so they can check it. I don't know, this is one way to go, but just I would like to mention that since I heard about this today. Yes, there are some systems, CoreOS and MicroOS and Cubic, that they commercialize them as, if you're going to run containers, use these distributions. Why? Why I can't use my normal desktop distribution and you tell me this is best? I have the same packages that you guys have. Well, first thing, since these are commercialized distributions, they have a read-only file system usually. They don't want something that escapes your container, writes stuff on your system. That's one thing. And the second thing is, Since everybody runs containers now in Kubernetes, and they also come with a platform to bootstrap Kubernetes, they don't want you to start manually configuring those things, because then there will be a hell for the support. Like, I did this and that, it doesn't work. Yeah, you shouldn't do that, actually. So the read-only file system also helps in these two ways. To basically protect the user of doing something stupid in terms of deployment, in a production deployment. And the second, it's a layer on top of security that something cannot go and write stuff in your etc folder and mess your configuration and stuff like that. Apart from that, as I said to you before, most people are using Kubernetes nowadays. Anybody here have used Kubernetes? Cool, cool, all right. And the problem with that is now, instead of hacking the containers, people hack Kubernetes. Since this is the platform, this is the orchestrator that is going to spin up and spin down your containers, if somebody gains access into your Kubernetes cluster, then your cluster is pretty much up to his desires. What happened recently, what I was about to tell you before, there was an incident about a bank that they had basically no authentication in their Kubernetes platform. Now you may ask how this happened. Once again, new technologies. The typical dinosaur Linux administrators are not there. They say, no, I know virtual machines. These are too hipster for me. So you have new guys. New guys are like, I know everything. I can go to YouTube, see how to set up this. I can do the tutorials. You know, I'm also on Twitter. So that's what's happening. They copy and paste documentation from there, and out of the sudden, all your secrets are ending up in GitHub, or no airbag in that case. So really, really easily, experienced hackers can hack Kubernetes in that case. It's not fault of the Kubernetes, it's fault of the guy who maintains Kubernetes, because it's very, very new, and we don't have the experience. We lack the best cases, like the best practices. If you Google for best practices, you see everybody has a best practice of its own. That's why in the upstream world, now kubeadm, which is one of the projects that can bootstrap a cluster, they try to forcefully apply some patterns for you. Of course, you can do what you think, but they say, you know, if you want a cluster with HA, for example, this is the best way to do it. So based on bugs and feedback and hacks, they try to fix all those things. And especially, containers are also heavily used in testing. So you might not have an app that gains some value for you, but you just want to test your scripts or your software. So you might need containers only for testing in that case, your app. There have been many incidents that the system that you use for CI and CD, continuous integration and continuous delivery, was also poorly set it up. So people can also hack those. The reason I'm mentioning this is because this is, if you Google for it, that's where the first problems arise. So I would say the problem with containers is that there is no any standard way of doing something except of the Docker. And now that we go outside of the Docker with other platforms managing stuff, we have to really learn and educate ourselves how these things works. For example, this year in KubeCon, everybody was talking about serverless. Who knows what serverless is in this room? Cool. Okay, you've been to my talk, right? So serverless, for the rest of the guys, is when I come to your server room and I steal your servers. Not really. In serverless, we instead of microservices, we use functions. And then we have some other ways of authentication. Normally, in the web, when you visit a website, a cookie goes down with, it gets downloaded to your PC and makes sure that you are the guy who's supposed to be. This happens only once, and then you are authenticated, pretty much. In the fast way, function as a service, serverless, they have JSON web tokens, which means every time you submit every time you ask for a function, every time you get authenticated individually. So in case you're interested in serverless, make yourself a favor and study about JSON web tokens to see how the authentication works there. What else we can talk about? Yes. And because the containers, the way we know them today, are using your kernel, they are using your system resources, there are people that they try to change that. Do you know about kata containers? Who knows kata containers? Good? One guy. So kata containers is basically an approach that some people say this is something that we are interested about security. Intel, I think, is pushing this also. Some developers from Intel are working in the kata containers. And what it is. A kata container is a container inside the virtual machine, basically. So they have a very minimal optimized virtual machine. So they spawn the virtual machine up, and inside this virtual machine, they run a container. And you, as a user from the outside, you still use the same commands as using Docker in that case, like Docker start. But what's really happening is actually spawning a virtual machine, and inside you run a container. So you have the isolation of the virtual machine. There is a kernel there inside, not your host kernel, the virtual machine's kernel, and you are isolated. That's one thing happening about security nowadays. So it's commercialized as we take the best of containers fast, and we take the best of virtual machines isolation. So it's this combination of those. Is a new project. Google for it, read for it. Maybe you have a use case for that. And another recent thing that came up with Google was the gvisor container. There they have built their own kernel written in Golang. So you basically, since the container has its own kernel, doesn't see your host. Yes, Marcus? Okay. If you go to their documentation, they say it's kernel. So that's what in the bug. And that's pretty much all the tips I had to say to you. I don't know if you have to share any experience you had in the past about containers, but for me, that I see how things are happening. I see people don't focus on the security at all. When, for example, you see an app getting built and you go and see what are the tests there are no tests about security. There is no security assessment there, nearly nowhere. So that's one thing. And the second thing is that people should educate themselves a little bit more about containers, not just grab some commands and do it in that case. Yes?
So my lab has been getting into containers some, and something that's always been a problem is there hasn't been any kind of user-level container creation mechanism. Is that still the case? Or?
I can answer that.
Yeah, give it to Marcus.
Can you repeat the question?
Yes, let's repeat the question.
So my lab has been working with containers some, and a problem that we've bumped into a ton in the past is that there's no user-level container creation mechanism or ability to run containers as a regular user instead of a root-level user. Has that changed recently?
I know Cypher from our Docker team is working on user space containers so that a normal user can launch it. But he still had to get some patches upstream. If you search on YouTube for it, his talk on this is public.
Anything else that you guys want to add? Yes, upstairs.
Just use common sense when downloading containers, like look what's going on in the container before you start running them.
Yeah, that's the first thing, yes. I mean, the first approach, the hello world, is if you go to Docker and search, is just go to Docker Hub, fetch an image, run it. Yeah. But also, what I would like to say is that I was checking, there is a very good video from Canonical that they market their Kubernetes solution, and they have 3 videos, how they build it, how they test them, and how they run it. And I was interested to find how they test it. And basically, they run the full-blown Kubernetes test suite, in that case, the end-to-end test suite. But I was, again, expecting, like, okay, my Kubernetes cluster is compliant with what a Kubernetes cluster can do, but what about security? I would like to have some security tests there also. Yeah.
So one thing I always find weird about people running containers or also VMs is most stop thinking about it after install. It starts, it runs, and I'm done. But you know, you want to get updates in them, and then you need a system that tells you, okay, this container has a vendor update for this package. And many systems don't have that. We get it now for OpenSUSE with the build service where we can build Docker images. So the system sees, okay, this package was updated, I need to rebuild this container. But if you deploy something, also think about how to maintain the lifecycle. And not just like, I started, I run it, and then I keep forgetting about it.
Yeah, one of the problems that people don't think is the day 2. Day 1 is, this is running. Day 2, I have to now apply an update. How I apply the update in that case, that I make sure that all of my containers and the replication controllers for those replicas have the same packages, for example, or what happens if the ATCD node goes down and I have no backups and all those things. Anything else from you guys? I would say go and Google for rootless containers. That's something I was looking recently. So when you go into the container, you are not root, you are normally a user. This is another approach, and I know there are also another initiative of people that they try to mitigate the impact of C groups and namespaces to limit the things that you can do from the container to the whole host system. Yes.
One thing I learned this morning actually is, if you haven't seen the LSM talk, they are working on that you can have an AppArmor profile on your host and then AppArmor profiles for your container, which restrict things even more. And they're working that it also works with SE Linux and other solutions. So soon you can have also like extra protection for the stuff that runs in containers. And it stacks properly.
So my lab, when we're working with containers, we've been using a system called Mesos instead of Kubernetes.
Right.
And it uses C groups to limit the CPU and memory usage of the containers being run, which is fairly helpful for our situation where we're trying to run fairly simple software that does data processing that needs to be able to run on unconfigured systems fairly easily. The problem we've had in the past was the software, we would have to set it up either to have a uniform set of servers that ran the software or set up installers to build the environment. And this way the developers can set up their own environment and then we can limit just how much CPU time and stuff they're using on our system.
That's good.
This is not specific to the runtime. This thing, and now we want to switch to Kubernetes, and there is probably flags in your Kubernetes runtime tools that you can say, okay, CPU share for this is this, and memory share is this.
Yes, we just found Mesos was easy for what we're trying to do in this case.
So runtime doesn't matter, whatever makes you happy. For me personally, it's always just a question like, how much isolation do I need for my customers? So if I can get by with a web server virtual host, then I do that. If I want more, then it's a change root or Docker or a VM or hardware partitioning or real machine. So always, basically, you can use the same workflow you use with containers. You can also do it with VMs. And if you need the isolation, then do VMs. If you see, I'm not sure who has seen from the Kubernetes conference, the talk from Kubernetes at CERN. They have 320,000 CPUs, 384 petabyte memory in their Kubernetes clusters, because they run 210 or something. And they basically have multiple clusters, so they can give each one admin on their own cluster, which run on top of OpenStack for self-management for the hardware. So it's just a question like what isolation, what access control you need, and then you split it up.
Anybody else? Any comments? All right. Then thank you for attending it. I don't know if I was up to your expectations for this talk. Thanks.